Example 1. Express 3x over x plus 1x minus 2 in partial fractions. We want to express that fraction in partial fractions. And for a denominator that looks like that, two linear factors, that's just going to be a over x plus 1 plus b over x minus 2. Next step in partial fractions is to say that 3x would be equal to a times x minus 2 plus b times x plus 1. Because you're matching up the numerators on both sides there. Next step, we want to find a and b. So to do that, I like to use substitution. So let x be equal to 2. If we do that, we get 6 on the left-hand side. And then 2 minus 2 is 0, so the a component goes away. And we're just left with 3b, therefore b is 2. And now to make the b component disappear, we can let x be equal to -1. That will give us -3 on the left and then -3a on the right, which means a is just 1. Therefore, we found the partial fractions. The answer is it will be 1 over x plus 1 plus 2 over x minus 2. And that's it. Part B, we're now going to use our answer to part A, and we're going to integrate that original fraction with respect to x. So I'll draw the integral symbol first, integrate 3x over x plus 1, x minus 2 with respect to x, and then rewrite that using the partial fractions from part A. Using partial fractions makes it possible to actually integrate this now, because we know that the integral of 1 over x plus 1 is just ln x plus 1. Similarly, the integral of 2 over x minus 2 is just 2 ln x minus 2. Stick a plus c on the end and we're done. Example 2, find the exact value of this integral. Now this looks like partial fractions again because we have some factors in the denominator. But we have to be careful with this partial fractions because the denominator has a repeated factor. So if we write this out, 2x squared plus 3x plus 7 over x plus 1 squared x plus 3. When we split that into partial fractions, we have to make sure that it looks like this. So a over x plus 1 plus b over x plus 1 squared plus c over x plus 3. So just making sure that you have a fraction that has just the x plus 1 and then a fraction that has the x plus 1 squared as well. Then we do our usual process. So focusing on the numerators, we're going to have this. This part, it will be a times just x plus 1, x plus 3, plus b, x plus 3, plus c, x plus 1 squared. Now, if we do substitution again, we can let x be -1, and that will give 6 equals 2b, so b is 3. If we let x be -3, that will give 16 equals 4c, so c is 4. And finally, we could let x be equal to 0, and that will give 7 equals 3a plus 3b plus c. If we sub in the b and c from earlier, that is 7 equals 3a plus 9 plus 4. If you solve that, you get a equals -2. Now on this step, you can let x be whatever you like, but I always choose x is 0 to make the maths a little bit simpler. Now we know a, b, and c. We can say that in partial fractions, this expression can be written as -2 over x plus 1 plus 3 over x plus 1 squared plus 4 over x plus 3. And now we can take these partial fractions and use them to integrate the expression. So now we can go ahead and integrate using those partial fractions. So here we have the integral written out as partial fractions instead. And one thing to note is that the middle term there, the 3 over x plus 1 squared, that's just the same as 3 brackets x plus 1 to the -2. If you write it in that way, you might find it easier to integrate it. So let's go ahead and integrate. So term by term, we're going to have -2 ln x plus 1. And then it's going to be -3 brackets x plus 1 to the -1 plus 4 ln x plus 3. This is a definite integral with limits, so let's put those on, and then let's evaluate the limits. Notice that we want an exact value. So in this case, we're going to leave our answer in terms of ln. So I'll just substitute everything in carefully and then simplify. And final answer could look something like this. That's an exact value because it's in terms of ln, and they haven't specified any particular format, so that's fine. That's it for now. If you found this video useful, please do remember to like, comment, and subscribe to my channel if you haven't already. And do share this with anyone else you think might find it helpful. Thanks, and see you next time.